Hello viewers, so still your humble self, like to talk. So if you are just scrolling on this channel for the first time, please don't forget to follow, because I know at the end of the day it's going to be a testimony. Being here is not a mistake anyway. So today we are going to be talking about groups under abstract algebra MTS211. How do you define groups? A group, the J comma asterisk is said to be a group if the following properties hold. If the following properties hold. So there are some properties that must hold for you to justify your case of group. That is just it. Now the first properties is what we call closure. The first property is what we call closure. And don't forget, inside this group there is an operation. So that operation is going to be applicable to whatever kind of identity we are using. Okay? So now, going by this operation we have here, so I will say that x operation, this one define s operation y being an element of what? Being an element of group for all s comma y is an element of group. So that's the first instance. Okay, so there is no stress about that. So the second instance is, the second property is what we call the associative property. What do I call it? Associative property. Alright, for the associative property, x operation y operation z is an element of what? Group. It's just simple as that. So that's the associative property. Now, for the identity property, it's just for identity property. The identity property, it follows that there exists, we're talking about identity E in group, right? Such that x operation E is equals to E operation x equals to x for all x in G. That is it. This is what we call the identity property definition. Alright. So for the last condition, so the last condition is the inverse property. Sorry. So for the inverse property, how do you define that? For there exists inverse in what group? Such that x operation x inverse is equals to x inverse operation x equals to what? Equals to identity for all x in groups. So now you see all this is what we call a group. So this is the definition, the pure definition of a group. So something is said to be a group if these four conditions are met. If these four properties are met, then it is called a group. Alright, so there's no difficulty about that. So in the next video we are going to be talking about abelian group. Then we'll move to Kali table. Alright, turn on your notification button. That's just it.